Welcome to Metabolism Matters. I'm Jennifer Woolley. Today we'll be taking a look at using indirect calorimetry to feed critically ill pediatric patients. Let's take a look at a case. The case involves a 22-month-old female patient with community-acquired pneumonia requiring mechanical ventilation for life support. Upon admission, the patient was lethargic and showed signs of dehydration. Prior to her illness, she was a healthy infant at home with her family. The patient's nutrition parameters are as follows: length 85 centimeters, weight 10.5 kilograms, and anthropometric measurements were the 50th percentile for length and 10th percentile for weight. When this patient came in, she had a fever and she was hemodynamically unstable, and as I mentioned earlier, was diagnosed with dehydration and community-acquired pneumonia. To figure out her nutritional requirements, we first ran predictive equations which gave us a range of 788 calories per day to 893 calories per day. Now, I hesitate to use predictive equations with this particular patient for two reasons. The first reason being that predictive equations are often unreliable during severe metabolic stress. And the second reason is that the patient's metabolism is likely changing daily, which is typical when a patient is fighting an infection. Because indirect calorimetry allows you to pinpoint real metabolism more accurately than predictive equations, this patient is a great candidate for IC. To confirm that the patient's metabolism does indeed vary day to day, take a look at the numbers we obtained using indirect calorimetry data. On hospital day 7, the patient's resting energy expenditure was 755 calories per day. It's kind of cool to take a look at where we would have been with feeding this patient with predictive equations. Depending on which predictive equation is used, we may have underfed or overfed this patient. Well, that's it for today. I'm Jennifer Woolley for Metabolism Matters. See you next time.